So yeah, several different amino acids, and you've seen that all of them are polymerized together. You can see that all of them are polymerized together, and and when they are polymerized, each amino acid in the polymer, each amino acid unit in the polymer is known as an amino acid residue, because it's not exactly the amino acid, it is a part of that amino acid. So the primary structure is the sequence, because I told you the order is very important in condensation polymerization. So the primary structure tells the sequence between the sequence of amino acid residues, and covalent bonds hold the polypeptide chain together, because obviously there will be covalent bonds between these two amino acids, these two, these two, these two. The amide bond is formed because of covalent bonds. The amide bond itself is a covalent bond. So you can see that this is held together by covalent bonds, and this is known as the N terminal, because obviously there is the NH2 on the left, so this is known as the N terminal, and in acidic solution obviously it becomes NH3 plus, and this is known as the C terminal. So in Zwitter ionic state, the carboxylic acid group gives its H plus ion to the amine group, so this is known as the C terminal down below, and this is known as the N terminal. The order can be anything. This is the order for just one particular protein, and there are several different proteins. So there can be several different sequences. Now, we have also talked about N terminal and C terminal. So now let's move to the secondary structure. So the secondary structure is basically when this polypeptide chain, it folds. When this polypeptide chain folds, it can form two different structures. One is a spiral like this upon folding, or the other is that it can straighten out and it can form with the same, it can form hydrogen bonds with the same chain, like we did in the polyamide example, how they form hydrogen bonds. So these two are, so this is called an alpha helix. Alpha helix. The spiral is called an alpha helix, and these are called beta pleated sheets. Beta pleated sheets. So so these two, both of them are secondary structures, both of them can form, and the only important thing is that they are called secondary structures because they are stabilized by hydrogen bonds. Now, covalent bonds were the important part of the primary structure, but when the polypeptide chain folds and forms the secondary structure, then the hydrogen bonds are the significant types of bonds, because these are what hold the structure together, the entire protein structure together. So you can see that in the alpha helix there are hydrogen bonds between CO and NH, CO and NH, CO and NH, and in the beta pleated sheet as well, instead of a spiral, the polypeptide chains are parallel to each other, so there are hydrogen bonds between them. So it's very important for you to know these two structures. You should know how to draw these structures, because they ask you to draw them in the exam, so you should be aware about how you draw these structures. Now, then comes the tertiary structure of proteins. So the tertiary structure of proteins is basically further folding of the polypeptide chain, and what happens is that then this orange part becomes the polypeptide backbone. It is composed of the secondary structure, which means it has many alpha helices and beta pleated sheets, and then within the polypeptide backbone we can have several different bonds because of the R group. The R group, which is on the amino acids, they can result in several different bonds, because sometimes this R group can have the sulfhydryl group, which is also known as the thiol group, SH. So when two SH groups combine, when these two combine together, they form a disulfide bridge by a condensation reaction. They form a disulfide bond. So you can see the disulfide linkage over here. It's called a disulfide bridge because it bridges the gap between this part of the polypeptide backbone and this part of the polypeptide backbone. And as you can see here, it can have hydrogen bonds. As you can see here, it can have ionic bonds. And as you can see over here, it can have nothing but van der Waals forces. So because obviously these are non-polar groups, so they will have van der Waals forces between them. So the tertiary structure is very complex. It is stabilized by hydrogen bonds, ionic bonds, van der Waals forces, and disulfide bridges. So they are, so in the case of the tertiary structure,